what's the probability of rolling 2 critical fails in a row? First of all, what is a critical fail? A critical fail is when you roll a 1. Now that is without any sort of modifiers. So if you are playing a game where you get to add or subtract something from your roll, a critical fail is when you roll the 1 and that's before you add any or subtract any from those. Clearly this is inspired by tabletop and role-playing games, so we will look at the 2 most commonly used dice here. First of all, we have the 20-sided die right here. That is also called a D20 in the gaming world. In the mathematics world, you would call that an icosahedron. Of course, an icosahedron doesn't have the numbers on it. Once you call it a die, it implies there's some sort of labeling on it. If it's not stated otherwise, we assume those labels are 1 through 20. This one happens to have a different symbol instead of the 20. That's because this is a die from Magic the Gathering. The next die we'll look at is the 6-sided die, also called a D6. And mathematically, it's just a cube, 4 sides, all squares. The 20-sided die is 20 sides with triangles as the sides, and each of those triangles is actually equilateral. Okay, so let's get to the actual probability question here. We want to ask what's the probability of rolling 2 rows in a 1, 2 ones in a row. So in order to answer this, we first need to establish that rolling a die is an independent event. So what we mean when we say that 2 events are independent is that if you know the result of one, that doesn't affect the probability of the result being something of the other. So in this case, the first event would be rolling 1 die, and the second event would be rolling either another die or re-rolling the same die. So rolling 2 dice, those are independent events. Similarly, rolling 1 die twice in a row is also a collection of 2 independent events. Of course, you can extend this to rolling 3 dice, rolling 1 die 3 times, and so on. If you have learned about things like drawing or sampling cards or items with or without replacement, rolling a die is like sampling with replacement. So let's first ask the question, what if you were to roll a d20 twice in a row? What's the probability that they're both a critical fail? Well, since rolling the die twice is a pair of independent events, all you have to do is take the probability of rolling a 1 the first time times the probability of rolling a 1 the second time. Well, since it's a 20-sided die, and unless otherwise stated, you're to assume that the numbers on the sides are 1 through 20, we're going to have a 1 out of 20 chance for each of those. And that gives us 1 out of 400. Okay, so that means if you were to roll 2 dice in a row, each with 20 sides, 2 dice or 1 die twice, 400 times, then you'd expect one of those to actually be 2 ones. Now, that's not to say that's always going to happen. This is just probability. Weird things happen. We're also assuming the dice are fair. If they're not fair, okay, well then you got yourself a different situation. Okay, well what if you instead rolled the d6 twice in a row? Well, in this case, you have the same starting expression where you just take the probability of rolling a 1 times the probability of rolling a 1, but each of those is now 1/6 because it's a d6. And so in that case, it's only 1 out of 36. So you'd only have to roll that die twice, 36 times, and expect one of those to be 2 ones. Again, that could happen more than that many times. It could happen fewer. It could never happen. This is just probability. So let's extend this. What if you took any fair die and rolled that twice in a row? Well, let's say we roll a d(n), where n is just the number of sides, okay? So, for example, a d10 would be a die with 10 sides, and we are assuming they're fair. Okay, then the probability of 2 critical fails and often we call that crit fails, so I'm just going to be lazy and write that. Again, we take the probability of rolling a 1 the first time times the probability of rolling a 1 the second time, and so this gives us a 1 over n squared. We can generalize this one step further and say, what if we roll 2 different dice, or the same, who cares, okay? What's the probability that they both result in a 1? Well, let's suppose that we were to roll a dm, where m is some integer, 1 or bigger. 1 would be kind of silly. That would be like a Mobius strip, which just has one side. And another die, a dn, where n could equal m, okay, but again, it's just a positive integer. Then the probability that we roll 2 critical fails is, well, now we take the probability of rolling a 1 with the dm times the probability of rolling a 1 with the dn, and that gives us 1 out of m times n, whatever those numbers are. That's about it. I hope you enjoyed this video.